Let's solve an example in reinforced concrete structures. Let's have a section F prime C specific strength of concrete 3000 on the square inches, strength of 50,000 psi, which is great. Definitely that's great. 50 steel, and we want to calculate nominal moment. Let's see how we can approach this problem. So for starting any concrete problem, check based off ACI, we need to check rho minimum. So rho is the maximum of these two numbers. Check that our steel inside the concrete is not a cosmetic steel, that's a structural steel. So to check that, steel should be higher than a minimum available steel should be and higher than a minimum, which is maximum of these two numbers. Then there is you can calculate both of them and just pick the maximum of ACI 18 version 20. And there is an easier check to check the F prime C. Check the specific strength of concrete. That's smaller than 4,400 SI. This is the controlling one. The second term is controlling, and F prime C is bigger than this number. The first part is controlling. And the reason for that is if you, for example, weight 60 steel, place the numerator by reverse F prime C by 1400 4 psi, you can easily get value of 0.033 for both cases. And as soon as you just pick a number bigger than 4, for example, 500, you can easily see first part is definitely bigger than 200, so definitely this one is controlling because that would be maximum. That's why this is the controlling side. Whatever you nominate is, but because they are easily cancelled by each other, but whatever whenever your number is beyond 1440, the of the first part is going to be sub greater number, so that's the maximum. That's why F prime C is bigger than 4,444. That's the first term is control reason behind. But yet, if you want, you can calculate both of them and just pick the maximum. So in our case, F prime C is at 3000 psi in our problem statement. So that's definitely less than this one. So the second term is control, and our rate is 50 still 50,000 psi. So this is our and our available, which is 0 area of steel. So if this is your cross section, have some steel rebar's in there, density of steel, this is your say effective, the center of tensile rebars. That's area of steel, all steel over times d is the density of your steel. This is rho available. Should be higher than. So let's have our actual available, which is again AS over BD at 411, on AS of 6.25 inches squared. So B is 40 inches. So by dividing that, see that's way beyond. So Row minimum check is already covered. So to be about checking, just be careful. Double check the documentation at the very end of the process. So again, based off this block, bullet get A, height of A is height of this block is something less than neutral axis. It's AS times Fy over 5% of F prime C times B. So if you replace that at the equation, it just gives you A equal AS times yield strength, which is 50, either 50 or 1000. Have it 50 here, have C by number. So that's just the ratio between these two. 85%, B is 14 in section, so you can easily see that's all. As soon as you can get, you have your A, C is A over 1, 1 4, less than 4000, it's definitely 85, just gives us a 10 point, just of neutral axis height from top of the section. So that's our C10 inches. As soon as we have every point, and easily go calculate a but an arm times a force. Force is area times stress. So we have our stress like F5, we have our area of steel. We can get nominal moment of the section, either concrete part or a steel part. I do prefer to calculate steel, but you often gives you the same answer. Arm is minus AO, AO arm center of tensile steel to the center of compression domain. So if you so it just we already know A is V is mean area of steel and don't and just divide your number by 2000, just give you convert inches to feet and also kilo a kilo, so the based off kilo feet. So our moment is 567 pound feet and report 55 kilo pound. If you our problems finish here, but most of it are interested to design moment is not that's phi times m. As soon as you at v is 0.9 flexural, as soon as you divide that by 511, it just gives you 159 pound inches. So, and as soon as you can report it like design moment, phi times m, 60 kilopound. And for using phi 0.9, we need to have a tension control section. So we need to check the check if using this coefficient. Whenever you use the design moment, which is most often the time of the problem, check also ductility check. We must check the ductility check, which is this ratio of C over T. So again, we can jump to table of so C over C must check the ductility C over, which is this part, last column. So this is our column is number 50. So C over T should be smaller than 18. So our C over and D just the effectiveness. So 10 is 10.30 is our neutral axis. B for our section is effective depth 2 inches. Then easily see it's bigger than, and that gives us point. Definitely bigger than. So section is ductile. It's not ductile, and that section you have to redesign it. Thank you. Solve